Alright, in this video we're going to look at interpreting the output of an independent samples t-test. So if you remember from the previous video, we were comparing the mean total competency score of males and females, and this competency score was taken before starting their job. So we can see there was 31 males and 39 females in the sample, and the mean for males is slightly less than for females. Their standard deviations are about the same. This table down here is actually our t-test results. But before we know which line to read off the t-test, because you see there's two lines here, there's this top one and there's the bottom one, we need to know whether or not we should assume that the variances are equal or not assume the variances are equal. And we do this with Levene's test for quality of variances here. We're given an F statistic and then we're given a significance value. And what this test is doing, the null hypothesis is that the variances of the two groups are approximately equal. That means that the distribution of competency scores for males is similar in shape to the distribution of competency scores for females. And the alternate hypothesis says that the two distributions are significantly different in shape. So we evaluate that using the significance value. And we do this the same that we would do all hypotheses tests. We're comparing it to our level of significance. Now I've set my level of significance to 0.05. You can choose 0.05 or 0.01 depending on what your significance level is. Now this value of 0.604 is much higher than 0.05, which means that I'm going to accept my null hypotheses and assume that the variances are approximately equal. Now that makes sense because if we look here at the standard deviation, which is just the square root of the variance, we can see that these two values are very, very similar. So it makes sense that we can assume equal variances. So now we know to read the first line of these results. We can see our t statistic is minus 0.838, 68 degrees of freedom, and our significance value is 0.405. Now our significance value, we compare this again to our level of significance, which is 0.05. Now 0.405 is bigger than 0.05, so we are going to accept our null hypotheses, which says that the mean score between the groups is not significantly different. Now if we look over here, we are given a mean difference. Now this is obtained by taking the first mean, which is for the males, and subtracting the second mean, which is for the females. So if we have 40.94 minus 43.69, that gives us minus 2.757. Lastly, we're given a confidence interval. I've left mine at 95% because my level of significance is 0.05. And we're given a lower bound and an upper bound. Now this confidence interval is for the mean difference. So that means it's a confidence interval for this value here. So I can be 95% confident that the actual difference of the mean competency for males and females is between minus 9 and 3. That means that sometimes the men will have a smaller competency score than women, and then there's also a chance that the men could have a higher competency score, which is why we cannot say that there's a significant difference, because there's a chance it can go either way.